additive property of inequalities with integers. All right, so the additive property of inequalities says that if you add or subtract the same number from both sides of an inequality, that your inequality remains the same. So for instance, if I write the inequality 2 is less than 5, which is true, 2 is less than 5. And then I, let's say, subtract 1 on both sides of the inequality. So I do 2 minus 1 and 5 minus 1. My inequality becomes 1 less than 4. So while the first statement was true, 2 is less than 5, 1 is less than 4 is also a true statement. I have not changed the trueness of my statement by subtracting 1 from both sides. And I could do the same thing with adding 1 on both sides of my inequality. 2 plus 1 is 3, 5 plus 1 is 6, and 3 is less than 6. So the trueness of my inequality has remained the same. We can use this property to solve inequalities that involve variables. Now, on ALEKS, you're not going to see them asking you to graph the inequality on the number line or to write your answer in interval notation. However, you will be seeing that on the exams. So I'm going to put it into the videos to get you prepared, and I suggest that you use that to solve problems on ALEKS. So when you're solving them on ALEKS, do the part that they want, but then also graph it on a number line and answer in interval notation on your paper so that you're prepared for the exam. So looking at this, if you treat the inequality symbol as an equal sign, it kind of works out similarly. So this is an inequality symbol right here, and if this were the equal sign and I wanted to solve for x, I would subtract the 8 on both sides to get x by itself. And that's what we're going to do with the inequality as well. So I'm subtracting 8 on both sides of my inequality. That will cancel these 8's out. Negative 10 minus 8 is negative 18, less than or equal to x. Now, oftentimes we don't like to see the inequality with the x on the right-hand side. We want to see it with the x on the left-hand side. To rewrite your inequality, notice that the big side of the inequality is towards the x and the pointy side is towards the negative 18. We want the pointy side to stay towards the same direction. So if the points towards the negative 18 here, when you rewrite it with the x on the left, it should still point to the negative 18. This is the answer that ALEKS is going to want you to give. For the number line answer that I'm doing for the purposes of this video, I'm just going to mark negative 18 anywhere I want. We're talking about shading the numbers bigger than negative 18. There's an underline on my inequality, which means I'm going to fill in the circle when I plot it on the number line. And numbers bigger than 18 are going to go in this direction. That's my number line answer. My interval notation answer for this is going to be negative 18 to infinity. If you don't remember seeing interval notation, you'll want to look up that topic on ALEKS, and it'll explain more how to get your interval notation answer. Let's go ahead and do a few more examples. So here we have the inequality 20 plus y is greater than 4. We want to get y by itself, so we're going to go ahead and subtract 20 on both sides. When the 20s cancel, you have just a y left. The inequality symbol is going to come straight down. And 20 minus 4, or 4 minus 20 is negative 16. So we have y is greater than negative 16. This is the answer that ALEKS is looking for. For my portion of it, I'm going to draw a number line. I've plotted negative 16. Because there's no underline on my inequality symbol, I'm doing an open circle, and I'm graphing the numbers bigger than negative 16. The interval notation for this is negative 16 to infinity.